Hello, today we're going to take notes on probability of compound events with replacement. So first we're going to define what a compound probability is. It's the probability of two simple events occurring. It means you have to multiply the two simple events together. Example, you have 2 red and 3 blue Jolly Ranchers in front of you. Find the probability of selecting a red Jolly Rancher from the pile, replacing the Jolly Rancher, then selecting a blue Jolly Rancher. So remember guys that it is it'll make this problem easier if you drew a picture. So I'm going to draw 2 circles with red to explain that it is 2 Jolly Ranchers that are red and 3 circles that are blue. So we see that we have a total of 5 Jolly Ranchers. So we're going to put that total on the bottom of the fraction for both. And that P, that capital P, stands for probability. And it's asking you, what is the probability of picking out a red Jolly Rancher from the 5 Jolly Ranchers without looking? So the probability of getting a red Jolly Rancher would be 2 out of 5 because we have 2 red Jolly Ranchers out of the 5 total Jolly Ranchers. Now the blue, we have 3 out of the 5, so we know that the probability of picking out a blue Jolly Rancher would be 3 out of 5. But now, the question was, what is the probability of selecting a red Jolly Rancher, then selecting a blue Jolly Rancher? So in order to find that out, we have to multiply the two fractions together and then just simplify. So I'm going to write the two fractions, 2 over 5 times 3 over 5, and we know we can multiply the fractions by multiplying the numerator by numerator. That's 6, 2 times 3, and then 5 times 5 would be 25. We know that there are no common factors of 6 and 25, so we know that it cannot be simplified. So that would be our final answer for this question. So the probability of selecting a red Jolly Rancher, putting it back, and then selecting a blue Jolly Rancher would be 6 out of 25 times. Now let's work on some examples. Example number 1. One letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Remember, guys, that vowel means A, E, I, O, U. So we have the tiles right here, and we have a spinner right here. So we have 2 different events going on. So I'm going to first figure out the probability of picking out a vowel from the tiles. Well, we know that E is a vowel and we know that A is a vowel. So that's 2 out of 4 for the tiles. Now let's look at the spinner. For the spinner, we have A, B, and C, so we know that just A would be the vowel, which is 1 out of the 3 total letters we see there. Now what do we have to do with those 2 fractions? We would have to multiply them. That would give us the probability of getting a vowel in the tiles and spinning an A on the spinner. So 2 times 1 is 2. 4 times 3 is 12. So we have 2 over 12. That can be simplified because they're both even numbers, 1 over 6. So we know that our final answer is going to be 1 over 6. Make sure you simplify and reduce your fractions. Number 2, the spinner and the number cube shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or 4? So let's figure out the spinner first. So for the spinner, we're trying to not get the blue. So we have 1, 2, 3, 4, 5. 5 different colors, and just one of them are going to be blue. So we know that 4 of the colors are not blue out of 5 different total sections of color. And then we're going to look at the dice. The dice has 6 numbers. So if you are thinking about a standard dice, it has the numbers 1 through 6. We're trying to roll a 3 or a 4. So we know that on a dice, there's just 1 3 and 1 4, making 2 different possibilities out of the 6 total numbers that we have on a dice. And in order to figure out the possibilities and the probability of both of them, we know that we can multiply them, and that should give us our final answer. 4 times 2 is 8, 5 times 6 is 30. We can definitely reduce this because it's divisible by 2. They're even numbers. 8 divided by 2 is 4. 30 divided by 2 is 15. And then it can't be reduced any further because 4 is an even number, only divisible by 2 and 4 and 1, and 15 is not divisible by any of those numbers. So our final answer would be 4 over 15. And this is the probability of the player not spinning the blue on the spinner and then rolling a 3 or a 4 on the dice. Last question. There are 4 oranges, 4 bananas. Let's make this smaller. And 5 apples in a fruit basket. Ashlyn randomly selected a piece of fruit, replaces it, then selects another piece of fruit. What is the probability that an apple will be chosen 2 times in a row? So we have 4 oranges, 7 bananas, and 5 apples. Let's figure out the total. So in order to figure out the total, we would have to add all those up. 4 plus 7 is 11. 11 plus 5 is 16. So we know that the fraction should be out of 16. So we're trying to figure out what is the probability of choosing an apple 2 times in a row. So we know that we have 5 apples. And then we have the same number of apples, so 5 apples. So remember that, guys, this is just putting it back in that basket for the first event and then picking out another apple. Okay, so we have to just figure out how to multiply these. 5 times 5 is 25. 16 times 16, I'm going to do it on the side real quick. 6 times 6 is 36, carry the 3. 6 times 1 plus 3 is 9. 1 times 6 is 6, 1 times 1 is 1, add them all up, and that should give you 256. We know that 25 is divisible by 5 only, so 256 is not divisible by 5 because it ends with a 6, so we know that that should be our final answer for this. And that means the probability of picking out an apple 2 times in a row from this basket is going to be 25 out of 256 times. And that concludes our notes for compound events, probability of compound events with replacement.